I would like to introduce Monica, who's going to be speaking to us about machine learning.
Thank you so much. All right. So we're going to be talking about machine learning models gone rogue and how to reel them back in. My talk is slightly bit different than other talks that you've seen at this conference. I'm a huge data nerd, so it will be data focused. All right, so just to give a background, this talk was inspired by the book Weapons of Math Destruction. Who's read that? Yeah? It's a pretty good book. And then also a research paper that I found from Cornell about machine learning models actually learning too much. So a little bit about me. I'm Monica K. Royal. I'm a founder and chief data enthusiast of my company, Nerd Nourishment. Again, a huge data nerd. I help folks utilize data and analytics to make their lives easier, whether that's through consulting, corporate training, or career coaching. I'm also an instructor at LinkedIn Learning, and I have a podcast called The Data Podcast for Nerds. And a little fun fact is that I really love to dance and cook, but not at the same time because that could get dangerous. All right, so baseline, I just want to define information security in the way that we are going to talk about it today in this presentation, and that is the practice of protecting information with a goal to protect and ensure the safety and privacy of both critical and sensitive information. And so machine learning models rely on this type of critical and sensitive information for them to be able to make the decisions. So I thought it would be really interesting to talk about the data that's being used and how to protect that data. So machine learning models, everybody knows about these. They are programs that find patterns and make decisions. And those decisions that they are making pretty much affect everybody here today, right? And so the types of decisions here that we'll talk about come straight from that book, Weapons of Math Destruction. And so we'll talk about the underwriting process, which basically just makes decisions on whether or not you are worthy to have a credit card, a loan, a mortgage, maybe insurance. There's also targeted advertising. So basically allowing marketers to send out very personalized ads based on somebody's traits or purchasing patterns, etc. And then also there's the hiring process, basically finding who's the best fit for a particular role. So, as you can imagine, we're going to talk about the data that goes into these models to make this decisions. So, first off, with underwriting, credit card companies, they don't only look at your credit scores. They create and calculate their own e-scores, and they take lots of sensitive information from individuals. They look at your web browsing history, they look at your purchasing patterns, they look at what you're purchasing, who you're purchasing from, how often you're purchasing things. They're also looking at your personal income as well as the location that you are located in. And so all of this is taken into account to then make you create those decisions to see if they want to give you that credit card loan. So basically, say, for instance, you are a person from San Francisco that is logging into, I don't know, Bank of America, right? And you just did a web search for purchasing a Jaguar. You are going to be bucketed better than if you were from somebody from East Oakland that just searched for used cars, right? So those decisions are putting you into those different buckets. Also, with underwriting is insurance. So particularly, say, car insurance. This e-score actually does calculate from credit scores, but they're also taking some demographic information as well as your driving history. What's interesting here is that the credit scores themselves are actually weighted more heavily than, say, your driving history. We'll get into some examples later on that. So for the targeted ads, this thing's always so weird. All right. So for the targeted ads, for them to be so personal, you would think that all the data it needs to be collected from particular people for it to be so personalized, right? And also to mention that there's two different kind of types of ads that we'll talk about. So there's the typical ads. So say your pizzeria knows all about you. They know what neighborhood you're in, what pizza you like to eat, when you like to eat pizza, the time of day, the day of the week, etc. Right? So they have all of that information. And then you have those predatory ads. And that's when you are seeing those ads be sent out for, say, those high interest rate loans. And those are particularly sent out to people that are in poor neighborhoods, right? So those predatory ads are basically relying on people's anxieties, fears, desperations, etc., right? Another thing about these targeted ads, specifically the predatory ones, is that they could look like viruses, right? So a virus gets put on your computer in the background, it's running, it's slowing down your network, but on the front end, it presents itself as an ad saying, hey, you know, I see something's a little bit funky with your computer, maybe you should call us and we'll fix it, right? That's another specific ad. Another one that's really interesting are these fake job postings. And those are intentionally just posted to collect information, like your address, like your phone number. And I've actually seen it to where it's collecting people's social security numbers as well. Beware of those. All right, so for the hiring process, these models that are involved in the hiring process are typically churn models. And this is just trying to figure out how long or if a person is going to leave the company right after being hired, right? So they'll look at things like your resume, your employment history, how long you've been at employers in the past, etc. But what's interesting is they'll also look at how far you live from the job location, because it's assumed that if you live really far from the company, you're more likely to churn, because who likes driving to work? Except for if there's a good podcast on, maybe that's okay. Also with hiring processes, we are not currently, to my knowledge, being judged on our zodiac signs, but there has been a spike in employers sending out these personality tests. And the outcome from these personality tests are being used to make the decisions on the hiring. So as you can see, tons and tons of data that is being collected, and that data that is being collected, most of it is sensitive in nature, or what is called PII, right? And when you do have PII information, it's really, really important for you to protect that in case of a breach, right? You don't want those that information to get into the wrong hands. So that's when the topic of data anonymization comes into play. And really the goal of this is to remove all of that PII from your data sets so that if and when the data gets stolen, they don't have any information that is very personal and can be tied to an individual or to a company, right? So some techniques that we see are very common here are masking. I see this used a lot with social security numbers. Also, there's generalization. I see a lot of this used with HIPAA compliance. So you're not allowed to be storing some birth dates in some instances, but you can generalize it and turn it into an age to then trace that back to that person because it's not as identifiable. And then lastly, there's pseudonymization, which what you're doing is you are just creating pseudonames for the people. So the people's names are then, taken out of the equation as well. So those are really great techniques to protect the data from a data breach, right? But Kathy O'Neill, the author of Weapons of Mass Destruction, she actually goes a little bit further into this because the decisions that these models are making could cause harm for some individuals, right? So she says that we need to be able to disarm these weapons of mass destruction, or WMDs. She says, first off, we need to reevaluate the success metrics. So today, success equals profitability and efficiency, right? So I talked about that car insurance example, and they are weighting those credit scores more heavily than the driving records. And that's because they're making more money off of it, because it's really efficient to plow through those credit scores so quickly because of how available they are, right? So someone that has really, really great credit but a not so great driving record is going to be treated significantly different, vice versa, right? Also, there needs to be more feedback loops. So again, I'll talk about the credit scores themselves. They're actually really good at these feedback loops, where when something changes, that information then gets refed back into that model to change that model, because things change within the universe, right? So the models making these decisions should also change, right? So with the credit scores, say you forget to pay a bill or you pay a credit card off, you see that being reflected pretty much monthly with your credit score. The credit scores are also really good at transparency, right? You can log into Credit Karma, you can see your credit score, they can tell you exactly what's being used, they can tell you information on how to better your credit score, what you can do, steps to take, etc., right? But this transparency is not a thing for all of these models, say with the credit card companies that are calculating that specific e-score. You don't necessarily know all of the data elements that are being used for that score. Also, she mentions that regulations need to be updated. So the FCRA puts into place where if there is something wrong with your credit score, you're able to then fix that incorrectness. Also, the ECOA, they don't allow you to tie your gender or race to a particular person's credit score, right? Now, these regulations, they're not every company has to adhere to these regulations, right? So they need to expand this to, say, companies like the Lending Club. Also, the Americans with Disabilities Act, they do, in the hiring process, mention that you are not allowed to look at medical records and tie those to the hiring decisions. However, right now, they do not have anything for those personality tests that I mentioned. So that definitely needs to be looked into as well. Lastly, Kathy mentions algorithmic audits, which, being a former auditor, I love this so much. Basically, it's just auditing these models to make sure that the decisions are fair and not biased, right? I'm seeing a lot of trending topics around this lately, and so I'm really excited to see where this goes in the near future. All right, so why does this matter? Of course, it's all about protecting the privacy of the individuals and also finding the balance between preserving the privacy of those individuals as well as retaining that data utility, making sure that those decisions, that those models make sense. But also, there is a famous quote, data, it's easy to steal these days. It's not necessarily a famous quote, that's a quote by me. But I say this because there's a thing out there, I don't know if anybody's heard of this, but it's crime as a service, right? Yeah, so hackers are basically selling their knowledge in tools to make it easy to steal data. And I think it's upwards of $20 trillion of an operation right now. So there's lots of money there. Yes. Oh, that's interesting. I wouldn't, I probably. I can see that, but I think that's more like the white hat hackers. Yeah. So there's like hacking for good. Mm. Yeah. Yeah. I'll definitely look into that gray mark when I get home. All right. So why else does this matter? That paper that I mentioned from Cornell, basically they saw that machine learning models can actually learn too much from the training set. And so if that model is then hacked, the information can get leaked and they can recreate the original data set. So I won't go too deep into this. This is a very short presentation, but I will at the high level mention that what they did was they took images, they trained it on conventional training algorithms for image classification, and that's what you see on row 1. Then they have 2 different categories of attacks. They do white box attacks and also black box attacks. So the 2 white box attacks are row 2 and 3, that correlated value encoding and sign encoding. And you can see how 2 and 3, they do a pretty good job. They're a little bit pixely, but they obviously were able to pretty much recreate that original image, right? If we look at row 4, though, that one does a fantastic job. That one's this capacity abuse attack, and this one is actually a deep learning attack. And so it's fairly recently realized that those deep learning models can actually memorize labeled data almost perfectly. So that's why we're seeing that row 4 almost really perfect from row 1. All right, so the Cornell folks, what they concluded for their countermeasures is how to protect this from happening is to only collect absolutely the only necessary data that you need for the models. This is a technique called data minimization, right? Also, there's something called perturbation, which creates a bit of noise to the data set. So kind of just like jumbling it up and making it even harder to then re-identify it back to the original data set. And then there is a technique called synthetic data where you can just generate a made up data set that is not reliant on any realistic events or transactions. And this is actually a common method to use for some machine learning models. All right, there's also some sophisticated techniques that are rolling out. There's anonymity, K-anonymity. I'm stumbling on my words today, I apologize. But basically, this protects the privacy of individuals in a data set from being re-identified. And then we have iDiversity, which protects the privacy of groups. However, with this one, there's a lot of computational power into play, and also you lose quite a lot of data utility. But that's where closeness comes into play because that finds that balance of preserving the privacy while still maintaining that utility. Then there's some future trends that we see coming into play, which are very exciting. There are some privacy preserving AI and ML frameworks. As an auditor, I love frameworks. I love when there's guidance around how to perform some of your projects. Also, we talked about that advanced anonymization techniques, but also what I find the most interesting, and I'm really excited to see this pop off, is the cross-disciplinary approaches. So this is where you get folks from law, ethics, data governance, audit, all in the same room to talk about what approach that the entire company should take to make the most sense, right? And then, of course, we have educational initiatives where you just get the word out there, you get some advocates, and everybody on the same page supporting these initiatives. All right, a little plug for myself. I mentioned I'm a LinkedIn Learning instructor. I do have this course about protecting data for analysis and machine learning, and we go into more data anonymization techniques, specifically in Python, and practicing on different data sets and how you can do that. And here are some resources, and that's it. That was the end of, actually, that was 20 minutes on the dot. Woo, I made time. If anybody does have any questions, let me know. But if not, there is an ending, closing session. And I thank everybody for coming to this final session. And thank you, CactusCon.